So today we're going to start chapter 5. So chapter 5 is all on bonding. So now that we know what ionic bonding is, covalent bonding, now we're actually going to do the bonding between two elements and two atoms, and then we're going to start drawing what that's going to look like from a 2D. So if you remember, we talked about different types of formulas. We did empirical and molecular. Now we're going to start talking about structural. And so a type of structural formula is a Lewis dot structure. And that's what we're going to learn how to draw. Okay? So to figure this out, the basis of our Lewis dot structure is going to be based on Lewis theory. And so Lewis theory says that there are certain electron arrangements in the atom that are more stable. And they're going to want to achieve what's called the octet rule. So elements are going to be most stable when they have 8 valence electrons. This goes with our noble gas. Our noble gas has 8 valence electrons. They're so stable they don't react really. Okay? So bonding occurs so atoms attain a more stable electron configuration. The more stable, the lower potential energy. So we're going to lower the energy, make it more stable by making bonds, and they only are going to make a bond if we're going to be able to reach this octet rule and follow that. So why is this going to be helpful? So Lewis theory is going to allow us to make a lot of predictions. A lot of things we'll be able to determine based on this Lewis theory. First, Lewis theory allows us to predict the formulas of molecules. Excuse me. Promise, not a COVID sneeze. Okay? So we're going to be able to predict the formulas of molecules. And so we can write formulas based off of names and whatnot. But so far we haven't really learned, well, why is this a formula? Why is this not a formula? So this is going to help us to be able to make those predictions. Lewis theory also predicts that some combinations should be stable, while others should not. Okay? So now we'll be able to predict why we could maybe write the formula, but that formula might not occur because it might not be stable. Okay? And so these two kind of go together. If it's stable, that's how we're able to predict the formula, and vice versa. So the ones that are stable are going to result in those octets. So stable combinations result in octets. 8. Now, Lewis theory predicts in covalent bonding that the attractions between the atoms are directional. And remember, we talked about this when we talked about covalent bonding. If I'm sharing my textbook, I need to share it in between us. So where that textbook is at, the best place would be between me and the other atom. Not way out here, not closer to me or closer to the other atom, right in the middle. So the shared electrons are going to be most stable between the bonding atoms, because that's the best place for them. And then once those bonded atoms, bonded electrons are shared between, then this is going to result in molecules rather than an array of atoms. Okay? So an array of atoms is what happens when I have my ionic. You have a cation, anion going up and down, left and right, forward and backwards, all of that. Where a molecule, you're going to have bonds, and we'll have an actual 2D structure. So in this chapter, when we're drawing the structure, it's only for molecular compounds. So what type of bonds can we form? Okay, so there's going to be 3 different types of bonds that we can form. The first are single covalent bonds. So if I have a single covalent bond, this is when 2 atoms are going to share a pair of electrons. So this is when 2 atoms share a pair of electrons. So a pair, it means 2 electrons. Now, when I say that an atom is going to share 2 electrons, that doesn't mean that an atom can only have one single bond, and that's it. An atom may have more than one single bond. Okay? But a single bond is 2 electrons. So I draw my Lewis dot structure for my elements. We did this last chapter. Fluorine has 7 valence electrons, so that's why I'm my 7. Okay? And they want to share. So to share, to make a covalent bond, they each are going to put an electron in. So he puts an electron, he puts an electron, so they each put an electron in the middle and share between. It takes 2 electrons to then make a bond. So this is how we draw a bond. This is a single covalent bond. One line represents 2 electrons. Now this is where each one of these only makes 1 single bond, but you could make more than 1. So here oxygen has 6 valence electrons, hydrogen has 1. Oxygen wants 8, and so what happens is hydrogen is going to put one in the middle, oxygen does. Hydrogen put one in the middle, oxygen does. I said it backwards, but you know what I'm saying. Okay? Now, when you see this, let's go ahead and do the picture. So now there's 2 here and 2 here. So now oxygen has 8. We're going to talk about how hydrogen is happy with less than 8. That's an exception. We'll get there. So now that I have 2 shared between, those 2 make a single covalent bond. But if you notice here, oxygen has 2 single bonds. Okay, so an atom can have more than 1. It just depends on how many they start with. And we'll practice on how to draw these. You'll be able to draw this and this at the end of this chapter. So 1 bond, 2 electrons. So what if I said it was a double bond? If it's a double bond, if each bond is 2 electrons, how many total do I have here? I have 4 electrons, or I have 2 pairs of electrons. However you want to think about it. So here, the oxygen is going to put in 2. This oxygen is going to put in 2. So I have 2 that are deposited or donated by each oxygen. So these 2 can make a bond. These 2 can make a bond because they're in between, they're shared. So that's where I get my double bond. All right, what if I have a triple bond? So if I have a triple bond, that's 3 bonds. Remember, a bond is 2 electrons, so how many total electrons is that? 1, 2, 3, 4, 5, 6. So this is 6 electrons, so this would be those 2 atoms are sharing 3 pairs of electrons. Okay? So the nitrogen puts 3 in the middle, this nitrogen puts 3 in the middle, so they each donated 3. It takes 2 to make a bond, so we have 1, 2, 3 bonds. All right, so those are our 3 different types of bonds. We have single, double, and triple bonds. So now we're going to talk a little bit more detail about these bonds and where these shared electrons are when they're between. Are they all the way in the middle? Are they towards one side or towards the other? And that will be for bond polarity on the next lecture.